Okay, so for this review, we're going to be doing the polynomial fitting technique from Module 7, and this problem is from Quiz 7. And we're using it to find the nth term for the sequence 1, 2, 4, 8, 15, 26, starting at A0. So the first thing we'll want to do here is find the first order differences. And for this one, that's 1, 2, 4, 7, and 11. Because these aren't a discernible pattern, it definitely means we want to be taking another difference here, and we'll be stopping once it's a constant difference. So our second order difference is 1, 2, 3, 4, and this is an arithmetic sequence where the differences have a constant difference of 1. So we'll take one more difference, and we can see that this is a delta 3 constant sequence. And because it's delta 3 constant, to find the nth term, we'll be using an cubed plus bn squared plus cn plus d. And now we'll be setting up a matrix to get the coefficients a, b, c, and d. And we'll do that by setting them equal to the terms in the original sequence. So A0 is equal to 1, and our n values here are going to be equal to 0. And that leaves only d. So our first term is equal to d. And we'll set the first term, the first term of the sequence, and that's equal to 2. And we'll set n to 1. And our second term is equal to 4. And simplifying this, that's 8, 4, and 2. And the last term we'll set is A3, and that's equal to 8. Simplifying that, that's 27, 9, and 3. So we could set up the row matrix, including this D within the matrix, or we could technically leave it out because we're certain that it's equal to 1. I'll include it in this, but technically you don't have to, and you would just reduce the matrix to not include that. Okay, and to be calculating this, using an online reduced row form calculator, so I'm going to be putting that in and getting those coefficients from there. Okay, and if I put this in right, we have 1, 1, 1, 1 and 2, 8, 4, 2, 1 and 4, 27, 9, 3, 1 and 8. That looks like it goes to 1, 6 for A, 0 for B, 5, 6 for C, and 1 for D. So then we plug that back into the formula. We skip n squared, include n, and set D to 1. And that should be how we get A of n. So it's pretty simple. The main thing is just making sure that you're putting the right numbers in to the grid. That's really it. And then for this to work, it has to be a sequence that you can get to a constant difference. And this equation will be based off of how many orders of differences you take from the original sequence. So this one we did 3, and we're using this method of getting an. And that's how you do quiz 7, question 2.